Hi guys, welcome to today's video. In this particular lesson, we're just gonna go through some alkanes and alkene reactions. So let's get started. So before we look at the chemical reactions, we're just gonna look at some of the physical properties. That's way too big. So physical properties, just it's alkenes are very similar in terms of physical properties. Despite alkene having a double bond and having more reactions and stuff like that, but the physical property is very similar. They are all nonpolar. So what it means is that if you so it's insoluble in water, so if you put it with water, it's not going to dissolve and it will give you two layers. Okay, so that's how you know you have an alkanes or alkenes. Okay, you got two layers, and they normally their melting point and boiling point increases as the number of carbon increases. Okay, so that's just the case for any organic molecules. And once you learn intermolecular forces like temporary dipole force attraction in year 13, you will understand this more. Other than that, they are normally the shorter chain alkanes are gas at room temperature, but then they can become a liquid if the chain gets bigger. Like the basic example, if you think about it, like think of methane gas is a gas, and then if you think about octane, which is in petrol, is a liquid. Okay, so this depends on the number of carbons, which is relevant to the stuff over here. Okay, because the boiling point and melting point changes depending on the number of carbons. Other than that, they're all colorless. That's a physical property. They're colorless. You can't really distinguish them by just looking at them. They're colorless, and yeah, that's about it really. And they all combust, they all burn, but that's something that we can look at in the reactions. So one of the minor reactions that we look at is combustion. So this doesn't really bother us at year 12 anyway. So with a combustion reaction, this is just whatever the alkane or alkene you have. You just react this with oxygen. You just burn this in oxygen, and then if it completely combusts, you're gonna make CO2 and water. And then depends on how many carbons you have in here, then you need to balance the reaction. Balance the equation. So this is complete combustion, and then you may have incomplete combustion, which is just you do the same thing, but you make carbon monoxide and water. And sometimes you just make carbon soot and water. So this is minor. This is really minor. I wouldn't spend more than 2 minutes on this. It's just something good to know. Okay, because we're using fossil fuels as an energy source. And how does that work? Which is just burning of the fossil fuels. Okay, so let's have a look at the chemical reactions. So the only one that we normally interested in is the substitution reaction. So if you look at alkanes specifically, we are looking at the substitution reaction. Okay, so the one in particular that we are interested in our syllabus is the alkane. I'm just going to do a simple one. React with bromine water and UV light. UV light, so sunlight. Okay, so let's think about substitution. So substitution reaction is, if you play sports or if you watch any sports, the word substitution speaks for itself. You simply take off a molecule, take off part of the molecule, and then you substitute it with something else. So what's happening here is that with one of the hydrogens at the end, it's always the hydrogens at the end because you can't easily get to the hydrogens in the middle. So what happens here is that because you're reacting with Br2, what's going to happen is that one of the H's and one of the Brs will swap places. Okay, so you swap places and you make the Br goes here, and then the HBr is produced on the other side plus HBr. Okay, so you had two Br2, so this is where your Br2 come from. Your Br2, you know, splits into Br and Br, and then one of them goes here, goes onto the carbon, and then the carbon replaces one of the H's with a Br. So you make that very simple. You just substitute. It's always the hydrogen at the end of the molecule. Like say you could be doing you could doing a lot of C's, and then you just have you know, CH2 with an H. I just want to show you that individually. So what's going to happen here is just the rest of the molecule doesn't matter, and then you just replace that H with the Br, and then you make HBr. Okay, so you could also work on this carbon as well. And if you do this reaction, if you leave it in there long enough, slowly and over time, you're going to actually replace a lot of the H's with the Brs, but that's not something we're interested in. We're just wanting for you to understand the basics of substitution reaction. You swap out one of the H and then put the Br. Now, the important observation here, is linked here. Bromine water is orange. Okay, and you go from orange to colorless in a few minutes. Okay, like 5 to 6 minutes. Okay, because what's orange? So the Br2 is orange. So let's say, for example, right, if I do this reaction plus Br2 and then UV light, and then this turns into that CH3, CH2, Br plus HBr. So if you think about the colors, why does it go from orange to colors? This is colorless, this is colorless, this is colorless, and this is orange. So this goes from orange to colorless, and that's where your color change comes in. And that's all the reactions you need to know for alkanes. Just substitution reaction. And then you can think about the combustion reaction as a minor thing. On the side, not something we really look at until year 13. Okay, it just burns. All right. The alkenes. Now, the alkene reactions are much more important. Okay, so I'll draw star signs all over this because alkenes does two types of reactions. Okay, and we're just gonna go through them. So the first one is what we call addition reaction. The ones that you learn in at this particular level, only alkanes undergo addition reaction because of the fact it has a C-C double bond. And this is the part I want to really emphasize on organic chemistry, is that all of the reactions take place around the functional group. So if you're just staring at a C-C double bond, what's going to happen to the double bond? I mean, if something was to react, obviously the double bond needs to be broken. So with this addition reaction, the C-C double bond breaks, and then you have this carbon and carbon that used to be double bonded. Now they need something else. So you add, the new atoms or new groups of atoms or group of atoms onto those carbons and then into the molecule. Then you have done the addition reaction. Okay, so there are quite a few that we need to go through today, so let's just get started. So we can do the same thing, like let's just do CH2, let's do ethene. So why don't we just do the same thing as we did just now with the bromine water. Okay, so this is one of the most iconic distinguishing tests that all the chemistry students go through. So you're adding Br2. So something that you really need to understand is that this double bond is going to break. So we're just going to copy it, but without the double bond. That's broken. And now you can see this carbon's only bonding 3 times, this carbon's only bonding 3 times. So what's going to happen is that the Br gets added there, the Br gets added there. Okay, and that's the addition reaction. You just break the double bond and add the things across. Okay, so so this is still colorless. This is still colorless. This bromine water is still orange. I was gonna write brown for some reason because of the Br. So it's still orange. So this observation, you don't need UV light for this. So this will go from orange to colorless straight away. this is going from orange to colorless straight away. Okay, and that's one of the distinguishing tests you need to know for this year. How you can distinguish alkanes and alkenes from the rest is that with the alkanes they do, with the bromine water, they need UV light, and this reaction is very slow, so it goes from orange to colorless very slowly. But then with the alkene, and why is it slowly? Because this is a substitution reaction, and with this one you just need bromine water, you don't need UV light, and this is very fast, and then you go from orange to colorless very quickly, and this is an addition reaction, and then you need to complete the reaction to show that. Okay, now this works with not just with bromine water. Let's say if I can add, let's just make it a little bit more difficult. Like say I can do chlorine water, I can do Cl2, and how do I do this? The same thing, right? Very simple. You just copy everything as you see them, break the double bond, and then just add the Cl and then add the Cl. Okay, just remember it never goes onto this carbon because you need to highlight the two carbons that were double bonded, and then whatever you need to add need to go onto those two carbons. Okay, so that's how, as you can clearly see, we're going from an alkene, we've gone to a haloalkane. Okay, so we've gone from, in this case, propane into 1,2-dichloropropane. All right. Now that's one of the reactions, and here we go. Here's another one. So if I do the same thing, let me do an easier one. So if I have alkene, now this is one of those things that you really need to remember. I'm going to do this in red. Okay, so you can do, they call this in different ways. They can write it as H+/H2O. They can do diluted sulfuric acid. Okay, so these two things that I've written down, they mean exactly the same thing. Okay, so you just need to be able to recognize them, and sometimes they write it like this as well. They write it as H2SO4/water. Okay, these three things, that one, that one, they literally are the same thing. They mean exactly the same thing. It's just diluted sulfuric acid. So the key word here is diluted. That means the key ingredient here is the water, the water. Okay, so the acid is just acting as a catalyst. What we're adding in is we're adding in water. Now, what is in water? If we can, we can break it down, from the sciences I did earlier, we know that water is made of OH- ions and H+ ions, and then they combine together to give you water. So what's going to happen here? So they break off into OH and H. You can simplify it like that, all right? And now we're just going to copy it the way it's the same logic, all right? I'm just going to copy the thing. I'm going to keep it exactly the same. I'm going to break the double bond, and then one of the C's gets OH and one of the C's gets H. Just like that. Okay, just like that. And this is where you may think, does it matter where the OH and H goes? In this case, it doesn't, because if you were to name this thing, this will just be called ethanol. Okay, because the OH doesn't matter if you put the OH here or if you put the OH here, it makes no difference. It's always going to be ethanol. But what happens if you get a larger molecule that's asymmetrical? So if you get something like that, let me just draw this beast. Let's put the CH3 here and put the CH3 here. So if we have this, let's do the same reaction. If I just add H2OH+, so I'm just going to write it the simplest way. So this means diluted sulfuric acid. Okay, so we're interested in the water. Again, we're interested in the water, so which breaks off into OH and H, right? So these two things need to go onto those two carbons. I'm just going to copy everything else as I see them. No, just break the double bond. No skills involved. This is where you get some of the reactions. People say so much to memorize, so much to remember. I can't remember all this. Surely you know how to do that. Just copy paste. Okay, just delete the double bond, and again, remember to just to highlight these carbons so you know what needs to be added. All right. So what do we need to add? We need to add an OH and H. I'm just gonna put the OH here. I'm gonna put the H here. And then you're probably sitting there wondering, why are you putting the OH on the left? Why are you putting the H on the right? Well, then you wonder correctly, because I don't. Who said I need to put it that way? I can, I'm just going to copy everything again. I'm going to do this in blue. I'm going to put the H here and put the OH here. So you got two products. Let's name it. Let's name this one. What's this one called? This is 1, 2, 3, 4. So this is 3-methyl. This is 3-methyl butane 2-ol. And what's this one? This what's this one here? This is 1, 2, 3, 4. So this is 2-methyl butane 2-ol. So you made two products because they're different, because the position of the OH is different, and you have made two different types of alcohol. Now, how do we know, do these occur around the same, percentage? Like, which one do I make more of? And this is where you need to remember this rule. Okay, this is where you need to remember this. You can remember it as the generic rule of the rich gets richer. When you're adding stuff, the rich gets richer. I mean, makes sense, right? Rich people get richer. That's the general law of economics. You got 10% of the wealth being controlled by 90% of the wealth being controlled by 10% of the people. That's just how economics works in this on this planet. So the rich gets richer, but don't write that in the exam. Please don't write that in the exam. You need to get that in your head. You just go, okay, so I'm adding stuff. Rich gets richer. Okay, so what are we talking about? What is the currency that we are comparing the richness? We are looking at the hydrogen. So you need to remember this. All right, you don't write this. Do not write this. Do not write this in the exam. So what you are going to write, you're going to say the carbon in the CC double bond with more H's, which is richer in the H's, is more likely to become richer in hydrogen, so it's more likely to gain another hydrogen. Okay, so this is a rule you need to remember. This is called Markovnikov's rule. Markovnikov's rule. Don't worry about the spelling, just really close enough. Markovnikov's rule. Rich gets richer. Okay, so this is a rule that the carbon, so if you look at these two carbons, so if I number these carbons, so this is carbon number 1, 2, 3, 4. So in this case, carbon number 3 is rich. Well, I wouldn't say richer. Carbon number 3 has more H than carbon number 2. You're not comparing 4 or 1. They're irrelevant. Okay, so we're only interested in the two carbons that are in the double bond. You just compare them. How many hydrogens are they directly bonded to? And then carbon number 2 is bonding to 1, and carbon number 2 is bonded to 0. So that means carbon number 2 in this case, can you see, got another hydrogen? So this is more likely going to take place. So this is our major product, and this is our minor product. So you get major, minor. So that just means the majority of the products that you are going to make is this one underneath, and you're still going to make the ones on top, just not as in higher as in the same amount of quantity. Okay, So in terms of an examination, like you just say, right, 2-methylbutane 2-ol is a major product. Why? Because carbon number 2, in this case, carbon number 3, before in the double bond already has more H's, so it's more likely for that carbon to gain another H. And the other one is minor. This one's major. Okay, that's like, you could here, because you're doing NCEA, this is one of the excellence questions. Let's do another one. Let's just put into practice a little bit more. Okay, so that's with water. I don't have to deal with water. I can also do this. I can also add HCl. right? I'm adding HCl. What's wrong with HCl? That it's the same as H2O/H plus, same type of reaction. You're adding that molecule into this molecule. You're breaking the double bond. Okay, so what we done? So same thing. Let's number them: 1, 2, 3, 4, and we're gonna break down. You're just gonna copy paste. If you were someone taught by me for year 12 and year 13, you must be sick and tired of me saying copy paste for organic, because that's what I say all the time. Okay, because all right, so we copy pasted. Now we can put the H here. We can put the H here. We can put the Cl here, or I can have the other option of putting the, again, just copy paste everything that you saw when you break the double bond. I can put the Cl here, I can put the H here. So you literally just swapped the position. That's all you did. And then let's come back to the molecule. Let's come back to here. We're interested in those 2 carbons. Okay, so which carbon is richer in terms of hydrogen? This one. This one has more hydrogen. So what does that mean? More likely to gain another hydrogen. All right, so it's more likely going to gain another hydrogen. So here it is. It gained another hydrogen. The hydrogen went to that carbon. So this is our major. This is our minor. Major minor products. Okay, and if you can explain that, that's an excellent question right there. Okay, so that's just because one thing that you need to consider, why don't I? Let's give you another one. If I move the double bond, if I put the double bond here in the middle, oops. If I put the double bond right here in the middle, and then I do the same thing, let's just do H2O/H plus. Okay, let's just do it again, copy paste, copy everything, don't, just break the double bond. Can you see I can put the OH here and OH here? And let's name this. This is butane-2O. All right, and there is no other product. And you may go, wait a minute, what happens if I just do? Why can't I put the OH on the other side? Like, who said I have to put the OH here? You can put the you can put the OH here. You can put the OH here, and put the H here. But then my question is, can you name that one as well? And if you name it, you go 1, 2, 3, 4. Yeah. Oh, wait a minute. This is also butane-2O. So you can't make 2 products. There is only one product. There's only butane-2O. It doesn't matter which way you put the OH, and you get one product. And why is that? Because of the symmetry. Hopefully you can clearly see that this is a symmetrical. This is a symmetrical alkene. So it makes absolute no difference where you put the H and where you put the OH. Okay, it makes absolute no difference. So because that's a symmetrical alkene. Okay, and if you go back to the ones that we've done before, I mean, if you look at that, this is clearly asymmetrical. If you go up here, you can see clearly this thing that we did here that is asymmetrical. Okay, so the symmetry determines what you got there. Okay, so as you can see with my alkene, depends on what you add. You can add Br2, you can add Cl2, you can add HCl, you can add HBr, and then they all become haloalkanes. Okay, they all become haloalkanes. And then you got your alkene, you can add H2O/H plus or diluted H sulfuric acid, or H plus/H2O, or H2SO4/H plus H2O. It doesn't matter what any one of those. It means the same thing. You turn that into an alcohol. So your alkene is really, really important because it's kind of like the functional group that connects a lot of the other functional groups together. Okay, so that's alkene. And that's the addition reaction. So the key thing with the addition reaction, you're breaking the double bond. You're breaking this double bond, and then they become single bonded, and then something needs to be added onto those 2 carbons, and that's what you need to realize today. And then there's another reaction, which is called the oxidation reaction. So the oxidation reaction is much more easier. So if you have, just go with a simple alkene, if you have this, CH2, CH2, then if you react this with MnO4- H+, what you are going to get, you're still going to break the double bond, and then you are going to gain the oxygens, and then with the hydrogen as well. So you gain 2 OHs, so you have formed a diol. And then, because we've done redox before, so if you think about that, that's this is purple. So the observation that you are going to get is that you have your purple stuff turning into the colorless stuff. Okay, you got purple going to colorless. This is also sometimes given as well if you just have MnO4- in a neutral condition without, so no H+, this will go from purple to brown. Okay, but this is more year 13, but you can get answers in year 12 as well. Okay, so that's the 2 key reactions you need to remember today. The alkene, that's alkane substitution is just literally kick out an H and substitute a Br or Cl. That's really it. But with the alkene reactions, you need to know the major minor products. The whole principle of breaking down the double bond and then adding things across. Okay, and then how that produces possibly 2 products, and sometimes when you have symmetry, only produces 1 product, and then we have the oxidation reaction here. Okay, so hopefully this is helpful, and yeah, I'll see you guys next time. Bye.